Perfect square equation is a quadratic equation where the first and the last term have a square root. What do I mean by that? For example, if you have a quadratic equation in this form, x squared plus 2xy plus y squared, this kind of equation is a perfect square equation. Or you have another one like x squared plus 9 plus 9. This is also a perfect square equation. And what do I mean? The first term and the last term have a square root. So what do I mean? So perfect square quadratic equation is that type of equation that if you take the first term and the last term, you multiply it by 2, it will give you the middle term. So now from here, this equation here, we can as well write it in this way. This is because when you take the square root of y square, square remove square roots, you have only y. Square root of x squared, square remove square roots, you have only x. So when you multiply x times y by 2, it will give us 2x y. So that is the middle term. So any perfect square equation is in such a way that when you take the square root of the first term and the last term, you multiply it by 2, it should be able to give you the middle term. So since this equation is perfect, we can as well write it in this format, which is bracket open x plus y all square. So this is an example of a perfect square quadratic expression or equation. So now let's understand it with examples. Let's take 2 examples here. We have example x squared plus 6x plus 9 is equal to 0. Let's just, this is a quadratic expression, and this equation here is perfect because there's ways of checking perfect square equation. The other way of checking it is b square is equal to 4ac, such that in any quadratic equation you should have, this is a format of writing quadratic equation: ax squared plus bx plus c is equal to 0. A, b, c are constants and they are called the coefficients. So in quadratic equation, a cannot be 0, b, c can be 0. That is, a is not equal to 0, but b, c can be equal to 0. That is, for example, if b is equal to 0, we'll be having equations such like x squared ax squared plus c equal to 0. So when the situation where b is set to 0. So now, since we have understood that, so perfect square equations can be checked. So now from this example that we have here, we can set our a to be equal to 1. We can set our a to be equal to 1 because the coefficient of x squared here is 1, and our coefficient of x here is 6. So we can set b to be equal to 6, and we can set c to be equal to 9, such that using this to know whether the equation is perfect, we know that our b is 6. So 6 squared is equal to 4 times a. Our a is 1 times c. Our c is 9. So now 6 squared is 64. 64 is equal to 1 times 4 times 1 is 4, and 4 times 9, that is, sorry, this is 36, and 4 times 9 is also 36. So this equation is perfect. So that has been satisfied, and again we can still check it by using, if you take the square root of the last term and the first term, you multiply it, it should give you the middle term by 2. It should give you the middle term. So let's check. Square root of square root of square root of 9 is 3. Square root of x will give us x squared will give us x. So 3 times x, then multiplied by 2, will give us 6. So that is, equation is says to be perfect, because we take the square root of the last term and the first term. When we multiply it by 2, it gives us the middle term. So that equation is perfect. Okay, so in solving perfect square equation, and this expression can be written in this form, that is x plus 3 all square. This is just the answer, and this satisfy that this is what, this is a perfect square equation. That is, when you factorize this, you're going to get this. Let's try it. In factorizing a quadratic equation, you should know that you look for the two possible numbers, that when you multiply it gives you the last term, and when you add, you should be able to have the second term. So guys, let's check it. What are the two possible numbers that when you add, you're going to have 6, and when you multiply, you're going to get 9? So here you can just find the multiples of 9. You can start with 1 times 9 is 9. 3 times 3 is 9. 9 times 1 is 9. So all these multiples of 9 is only 3 plus 3 that will give us 6. So we will know that the two possible numbers that if we add, we're going to get the middle term, and when we multiply, we're going to have the last term is 3 and 3. So since we know there are 3 and 3, we will now substitute the middle term by saying x squared plus 3x plus 3x plus 9, because 3x plus 3x is 6x. We have not changed the equation, so we now insert our brackets. So inserting the brackets, you have to factorize. You have to look for a common term for the common factor for first bracket and the common factor for the second bracket. And the common factor for the first bracket is x. So x squared divided by x, that shows that it's the same thing as x times x all over x, such that x cancel x will remain with 1x. So x squared divided by x will give us x. Then 3x divided by x, that is 3x divided by x. This is the same thing as 3 times x all over x. X into x remain 3. So which means we have only 3 here. Then the second bracket, the same thing. The common factor here is 3, because 3 3 divided by 3x divided by 3. 3 into 3 is 1. 1 times x will give us, so 3 is the factor. So 3 into 3x will give us just x, and 3 into 9 will give us 3. You will now discover that the two brackets become equal. So since they are equal now, we can now factor them out. Since this bracket and this bracket are the same, we factor by saying x plus 3. What remains is x and plus 3, and that is form the second bracket, that is x plus 3. So now you discover that the first bracket 2 is x plus 3, and the second bracket 2 is x plus 3, and this will result to bracket open x plus 3 raised to the power of 2 as what we got from the initial points. So this equation here is a example of perfect square equation. So, and again, so guys, if you enjoy what I have just explained, please help me subscribe to my channel and turn on the notification bell, so that anytime I post a video like this, you should be able to benefit from it. Thank you.